We'll see. Hey, hey, Urshers. Sorry, my short. I live like a 12-year-old, so I still have to wear shorts and like they're Nike shorts, and they just every time I sit down, I have to tug them down. But the biggest problem is that it have pockets, and my dress has pockets, so I'm like double pocketing it here. So I've got pockets and pockets. It feels so special. Yeah. Anyway, okay. Here we go. Periodic functions. Wait, Miss Smith just said something important. Anyone who might want some lasagna, you can go to Miss Smith's room and get some lasagna. Yeah, that's what I promise you that's what it says.
Right now?
She said send them up. So, yeah, go get you some lasagna like Garfield. Now, she's going to give away the rolls. It's the food from the sports banquet last night.
She's giving away
The
rolls?
rolls were like this big.
Oh yeah, they were huge.
They were huge. Like, I feel like there are some third world countries that's more food than they get in a week. That one roll. It was big. Yeah. Anyway, I'm going to ask her, are there rolls?
Or drinks.
There are no drinks. So we had to provide our own drinks for lunch today. So, hey, Urshers, you're missing awesome food right now.
So do we have time to run?
Yeah, we're going to write some definitions, but go for it. All right. What does anybody know what a periodic function is? What is it? Okay, it just means that they repeat, okay? They repeat forever. Like the same thing over and over and over again. It doesn't change. It's the same thing over and over and over again. Sine and cosine are periodic functions, okay? And the period of the function goes from one point to the next matching point. It's basically however long it takes for this function to do whatever it is it's going to do. Okay? So it's from one matching point to another. Kobe, if you want to go get some lasagna, you can go get it. If you don't worry, it'll be recorded. So you're good.
I had no idea what you were talking about.
All right, the amplitude, okay, is the height from the center line to the peak. Or if you're going from the center line down, it's to the trough. Yeah. Or you can measure highest to lowest divided by 2. Highest to lowest divided by 2. Miss Smith has not answered me on the rolls. And I did ask her if there were rolls, and she has not answered. Do they have what?
The olive oil and pepper, you know.
Oh, no. Mm-mm. They had little baby butters, though. That you could... Yeah, that was good. All right, is this a periodic function?
Yeah.
Does it do the same thing over and over and over again? Okay. It's a bunch of sharks. Yeah, it could be. Okay. Tsunami. All right. What's the domain?
I don't think
Well, if it's periodic, what does it do?
it repeats.
It repeats forever. So what's the domain? Negative infinity to infinity, right? You feel like, what? What? What's the range?
-3.
Hard bracket, soft bracket.
Hard rep.
Mm-hmm. Okay, so what's the period of this function? How long does it take it to do whatever it is that it's going to do? 2? So let's see. I can get matching points in 2 units. Like here's a point and there's its buddy. 1, 2, 3, 4. So it takes 4 units for that to do whatever it is it's going to do. You'd really just probably say 4, but anyway. Amplitude. Amplitude is 3. Yeah, because you've got 6 from the top to the bottom. Half of 6 is 3. Just 3. And that's really just 4, but you can put 4 units, but it's just 4. All right. How about this one? Is this periodic function? Yes. Okay. What's the domain? What's the range? What's the period of this function?
6.
Mm-hmm. And the amplitude? Is there a back? No. I need a new page. Is that a periodic function?
No.
Why not?
Because it doesn't repeat.
Doesn't repeat. Yeah. Yeah. There's definitely like a pattern there, but it doesn't repeat. It's not doing the same thing over and over again. Okay. You can still find like the domain and range though, right? Maybe.
Yeah.
Doesn't have a period, doesn't have an amplitude because it's not periodic. It doesn't, you can't split it in half because it doesn't. But domain, I mean, if this pattern goes on, what's the domain and the range going to be?
Negative.
Yeah, eventually it's going to cover everything. I mean, if that just keeps getting bigger like that, it's going to go on forever. What about this one? What's up with that?
It is.
It's what?
It is a function.
It's periodic. It does the same thing over and over and over again, right? Okay. What's the range or the domain? Sorry, what's the domain on this?
Negative.
Well, it has a bunch of breakpoints.
Yeah, it has a bunch of asymptotes, right? So let's see. It can't. How often does it have the asymptote? Every 3. So what if we said that the domain so we could say it's all of x such that x can't equal, we need 1 to start with. We start with 2. 2 plus 3n. Would that work? Does that work? Or 3k. You could say k or n, or you just can't use x or y. Okay. You might also see that it's k. If I put in like 1, that's 5. If I put in 0, that gets me at 2. If I put in -1, that gets me at -1. If I put in -2, that gets me -4. So yeah, it's going to go on like that forever. So that's the pattern right there. That's our pattern. Okay. How about the range? Yeah, it can be, the range can be anything. Like I can put anything in the range. So negative infinity to infinity. So how wide is this? We've kind of already answered that. 3. Does this have an amplitude?
One half of
Yeah, half of infinity, which guess what is infinity. So we don't have an amplitude here. Fire, ice. Is this one periodic? Why not?
because it stops.
Well, the other one stopped too.
Yeah.
Yes.
Well, why is, what is that? It doesn't have a dot on the other end.
It's still
But
repeats
it's still
itself.
periodic.
It's still-
Does it do the same thing over and over again?
Yeah.
Yeah.
It's periodic function. It does the same thing again and again. So yeah, we're gonna say
You said we chopped up.
yeah. Did anyone say you could call right now? By the way, I passed out summer assignments today. If you're going into calculus and you're not going to do calculus camp, you need to get a summer assignment, which I don't have the calculus one printed yet. But what I'll do is I'll post it in Google Classroom because like last year, everybody gonna go to calculus camp. They're all gonna go to calculus camp. And then one kid didn't go and he had to do a summer assignment. So if you don't do calculus camp, then you'll need to log into your Google Classroom. I'll give you the code for the calculus classroom. And you'll have to like download it and print it off and do the summer assignment on your own. So anyway,
But I didn't ever get anything over.
has anybody gotten anything yet?
No.
This is where
You got something? What'd you get? What'd it say?
accepted.
Maybe they don't want you.
Yeah, it's like-
When did you, when did you get that email?
It says like all the paperwork has to be done by 19th, and I wonder if we filled out everything online. So that we send it to me through email or something. She said she didn't have me. If they didn't show me, then I'm so.
I hate that for you.
I mean, it probably didn't help that I signed up like 3 days before like the deadline.
There's probably like a lot of people that signed up 3 days before the deadline.
I signed up today.
At least I was 3 days before.
How am I going to take care of it?
You're gonna call them.
No.
Crystal don't be calling.
Yeah.
Yeah.
Crystal, you signed up without telling your mama?
She's a girl.
She don't be this. She gonna say Evan, my favorite child. Avery. I'm Hunter. Hunter who? You mean Greg? Oh, well, I saw what she posted about. My baby boy's a senior now. What's the time going?
Did she say
She
that?
did. I didn't see it. I don't know if she said baby boy, but
No,
she
shut up.
said
Shut
senior.
up.
The word senior was there.
She said, my oldest is a senior. Something like that. She said, I love you so big. When are you walking?
Okay. Anyway, what's the domain on this? Well,
No.
can it be this? Can it be that? Can it be this?
It's x and x is not equal 1 plus 4.
Let's see. Can't be 1. Yep. Works. Wait, about what? About roles or about summer camp?
look, we're worried about
I actually
what
haven't found out anything about either. I just wanted to clarify.
Just care about the rolls. You're worried about movement
Yes.
and not the rolls.
And not the rolls. I know you need to like work on your priorities. Just saying. Those rolls were good. Okay. All right. What's the range?
soft bracket, -2 to 4 hard bracket.
Oh, you're backwards.
Ah,
So close, Garrett.
The other way.
The other way. Yeah.
I had it right on my paper. No, you didn't.
Did she?
All right. How about the period of this function? And then the amplitude? 3. All right. Okay, so let's look at this.
How long was the junior high banquet? Like an hour or something?
It got done at like 7:15, 7:20. Yeah.
We stood up there while
And I
Coach
left
talked.
early.
Coach talked for 37.
I left early, but I didn't feel bad. Like I felt like they wanted to leave. That's why they rearranged it so all the sports that included ninth graders were first. You notice they did them out of order, and all the sports that had ninth grade in it, they bumped to the front. And I feel like it's because we'd already been there 2.5 hours, so that's why they. So I got out.
I think they should limit how much somebody can talk.
I heard that.
Like get one of those hooks, like they pull people off the stage.
Yeah.
Yes,
They said that they were gonna do the
that's the job I
fall
want.
sports.
Yeah.
Like before Christmas, and then do all the
That's a
winter and
fantastic
spring.
idea.
That's what really said today.
That is a
I like that.
And they did baseball
fantastic
second.
idea. Yeah, they did baseball second.
Probably 'cause they didn't.
Yeah, we didn't even get that award. Well, they wanted the ninth grade.
They want the. I'm telling you, it's because of ninth grade. Because that's not the order they did the junior high one in. The junior high was in a different order, and I feel like they did that because the ninth graders would have had, if they did it in order of sports like they've done in the past, junior high would have been there from 5 to what 9:20, 9:30. What time did y'all get out of there?
I left before football started. It was like 9 p.m.
Yeah. So
Stay the whole time.
I feel like that's why they did that, because they wanted us to leave. And since I am such a people pleaser, I left. So, yeah,
Shout out to Rex.
Yeah. Always trying to help.
I bet you this one thing.
What? Are you talking to me? Okay, let's do this. So we've got this table shows the cycle of one cycle of a periodic function. The graph consists of straight line segments that connect this consecutive points on the table. So look it over. Man, I really super remember doing this last year. Like I remember this exact problem, and that never happened. Based on the values in the table, explain how you know that this is one cycle of a continuous periodic function. How do you know that this is one cycle of a continuous periodic function? It goes back to 4. Yeah, it's from 4 to 4. Okay, that's how we know. That's how you know. I just every day I'm singing this. That's how you know it's from 4 to 4. Okay.
Oh, no, she's gonna be stressed. Gonna be stressed. So July 9th.
All right. Period and amplitude. What's the period?
7.
Why?
Because 7 units from 1 4 to the other 4.
It's 7 from 1 4 to the other 4. Okay. And then what?
That's all I know.
-4 to 3.
To get from here to here. So to get back to where it started, that's 7 units. What about the amplitude? Why?
It's have 6.
And where'd you get 6?
4 and -2.
All right, the high point and the lowest point, it takes 6 to get back. 6, so half of that's 3. Okay. What? What?
What if -2 wasn't the last one?
Then we'd have to, but it says this is one cycle. It told us this is one whole cycle. So we know that's the lowest point.
The only thing it's gonna do is that again.
Yes. And now they want us to graph it from -11 to 10. Well, we don't have -11 to 10. We have -4 to 3, but what do we know? It repeats. It's going to do the same thing over and over again. So we can graph the ones we know. -4, 4, 0, 2, 1, -2, and 3, 4. And all of these points have a match. How far away on each side?
So,
And how do you know it's 7? Because period 7. Okay. So this one, 1, 2, 3, 4, 5, 6, 7. And this one, 1, 2, 3, 4, 5, 6, 7. Oh my goodness, look, that one is that one because they're the matching point. I missed that point and I missed that one. Goodness. That's beautiful. What are the values of f of 15 and f of 77?
F of 15
Mhm.
2
How do you know?
because if you go, I don't know how to explain it.
Is it going to be 2 or is it going to be -2?
It's gonna be 2. Because
I think I should fight. I think let's settle it.
Fine.
No. All right. So
-77.
why is it going to be -2 versus 2, or why is it going to be 2 versus -2? All right, Kason, hit it. Not literally. I don't literally want you to hit anyone. You think it's +2? Did you change your mind?
No, I think it's -2.
Why?
Because whenever you add 7 to the point of 8 to -2, that's whenever you get F15. And so you're
Okay, so if this repeats every 7, right? So 15 minus 2 7s gets me to 1. Well, at 1, this function's at -2. So if I add 7, I'm here. If I add 7 more, I'm over here at 15. So it's gonna f of 15 is -2. Okay. 2 times 7 plus 1 is 15. So it's going to be whatever that one is. Okay. What about 77? Why 2? Why is f of -77 2?
I divided by
Divide by 7.
It goes evenly, and so you're gonna be right there. So that's it. Yeah. That's a positive too. All right, what about f of 64 and f of negative 25?
F of negative 25 is 4.
F of negative 25 is 4?
Yes, ma'am.
How do you know?
I went to negative 11, and it's 4, and I just added 7. I mean, I'm added 7 points off.
Okay. So you could say negative 25 you subtracted to get there.
Yeah, it is.
Well, if I add, does that make it, like if I said, okay, well, negative 25 plus 14
Yeah.
is negative 11, right? So it's going to be whatever negative 11 is, which is 4. Okay. F of 64 is 2.5.
You're at 2, maybe 2.
I think it's negative 2. I think it's negative 2, and I'll tell you why. Because 9 times 7 is 63. And that leaves 1. And at 1, it's at negative 2. So it's going to match up. It's so what are we looking at there to see what it matches up with? It's like, okay. Let's see. The closest thing that goes into negative 25 that has to do with 7 is 21, right? Negative 25 plus 21 leaves you with a negative 4 left over. Sorry, I couldn't add for a second. And at negative 4, we are at 4. So what you're actually looking at when you're trying to find these, you're looking at the remainder. What's left when I go through this period of this function? Because wherever you are on the remainder, that's what you're actually looking for. Like this one, I'm not going to draw this out to 64. I don't have the time or the patience or the skills because look how horrible that is. Okay. So 64 divided by 7 goes 9 times. I don't care that it goes 9 times. What I care about is that there's a remainder of 1. If there's a remainder of 1, then it's going to line up with what 1 is. So that's at negative 2. That's what you're looking at. It's that what's left over because that's what it's going to line up with. Remember when we did i's and we were like, what's I to the 48th? It doesn't matter how many times 4 goes into it. What matters is what the remainder is. And that's kind of what you're looking at here. Okay. Oh my goodness, it's homework time. Look at that. Look at that, boys and girls. So there you go. Day 80. Whew, day 80. Oh my goodness. We're so almost done. Day 80. You've got 2 periodic functions. And then you have to answer all these questions about it. And then you have to draw your own. Easy peasy lemon squeezy.
How many days are there?
83. Right? Or 82. You got your table behind this? 82.
No. Oh, it's like the whole year.
Oh, we go to school 180 days?